I'm Doug Atkinson here at Solutions Review, and I want to thank all of our panelists and speakers for participating in this quarterly mini jam. These events have been wildly successful for us, helping to drive over 700,000 subscribers to our YouTube channel in the first year alone. And of course, we are continuing to build the always-on community site at insidejam.com, where you can connect with experts like you'll see today, along with colleagues and peers, and continue the conversation around enterprise technology. If you haven't already joined insidejam.com, please do. And if you have, please invite a colleague to join as well. And again, thank you very much for being here and enjoy this event.
Solutions Review presents Inside Jam, an enterprise technology community.
Hello and welcome to the Quarter One Mini Jam for 2025. My name is Jonathan Paula. Glad you are here with me. And I'm also glad to bring with me 6 experts from around the globe as we begin our first panel of the day discussing scaling AI, building data architectures for the future. Wayne, Andreas, Carl, Richard, Tom, and Wei, thank you so very much for joining me. It is going to be a great discussion, I can already tell. Let's begin the discussion with some introductions, though. Wayne, you've agreed to moderate, so let's kick things off with some introductions, 30 seconds or less. Tell the audience a bit about yourself.
Sure. I've been in the data and analytics space for over 30 years now. I've been a research analyst, speaker, author, and consultant.
Excellent. Thank you for being here. Appreciate it. Next, let's go over to Carl. Welcome to the show.
Thanks, and glad to be here. I've been in the data management space for over 47 years. I've been a contract programmer, a consultant, a software developer, market product manager, and an analyst most recently for a company called IDC. And now I'm independent and I get to speak my mind.
Yeah, thank you all. Thanks. Glad to be here. And my name is Andreas. I'm SVP of growth at Graphwise, a merger between Semantic Web Company and Ontodex, just recently formed. I'm very excited to be here, 20 years plus around helping organizations to build semantic layers on top of their existing data landscape.
Excellent. Thank you for being here and good morning to you. Richard, you're up next. Welcome to the show.
Hi, Richard Winter, independent consultant focused on data warehousing and analytics at large scale. Done this for 30 years, mainly helping executives in large companies with their selection of a data platform and their development of a data architecture.
Excellent. Thank you very much. Tom, you're up.
Well, thank you very much, Inside Jam, for having me. Many know me as the data doc. I work with companies on data quality, and mostly that reduces to getting the people and organization stuff right. When you do that, quality improves rapidly. And when you don't, you tend to stay where you are.
Awesome. And last but not least, Wei, welcome.
Good morning. Wei Manfredi here. I'm leading the global architecture, data analytics, and AI for McDonald's. And I've been spending also 20-some years in architecture, data, and analytics.
Excellent. Thank you very much, one and all, for being here. Really appreciate your time. I'm going to get out of the way because I don't have any expertise on this topic, but Wayne does, fortunately. So he's going to kick us off with our first question. And good luck.
Great. Thank you, Jonathan. Well, welcome, everyone. We have, as you can see, a very large, illustrious, and I suspect boisterous panel today that collectively has probably close to 200 or more years of data analytics experience, as you saw from the intros. So this crowd has seen data architectures evolve significantly in the last 30, 40 years. Personally, I've seen us go from data warehousing and something we used to call enterprise information integration to web services and microservices to big data and Hadoop to cloud data and Spark to data fabric and data mesh. And what's interesting is that a good data architecture never dies. All these data architectures that I just mentioned still exist. And from our experience, still play a role in most data ecosystems, even if they've changed names over the years. But the title of this session is Scaling AI, Building Data Architectures for the Future. So after 70 plus years, AI has finally hit the mainstream in the form of chatbot applications that anyone with a computer and an interconnection can use. So the question for our illustrious panel today is whether AI, as a powerful new technology and set of applications, requires us to alter the way we've architected our data environments. We've always architected for scale, always architected for usability and quality. So what's different? So to answer that, let me first turn to Richard Winter. Richard, there's been an imperative to scale our architectures for several decades now since the era of big data. You've been focused on the scalability of the database, analyzing the needs of high-end customers, and testing the limits of data platforms. Does AI, in your opinion, fundamentally change our data architectures and the way we scale them?
It does, in my opinion. I think it's going to cause customers to move the AI operations close to the data, because in order to do AI at scale, you can't afford to have it involves intensive, complex interactions between the AI functions and the data, and you can't have them far apart or they just won't perform. And to give one example of this, so this is going to be the case with Gen AI, where we're going to have the vector embeddings directly in the enterprise data platforms and the enterprise document stores. And it also applies to machine learning, where we're going to have increasingly the machine learning functions embedded in the data platforms and performed at scale right there with the data. Both the training and the inferencing will need to be inboard in the higher scale cases.
Does any other panelists have a comment on Richard's comments?
I would like to add to what Richard said, in that if we're going to move we're going to move AI closer to the data, then we have to have the data in a form where it can be blended and accessed as a unit instead of a lot of small pieces, which is what is the case in a lot of enterprises today. Otherwise, what does it even mean to say we bring the AI closer to the data? So we have to have more control over the data, making sure that it's consistent and reliable and current.
Right. You're also saying we need to bring the data closer to people.
Yes.
So, Richard, we've always embedded functions, statistical functions, math functions, variety of functions inside the database. Are you seeing that we're going to be embedding other newer types of AI functions to get us closer to the data?
Yeah, well, it's interesting. The tradition in data science is to do, for example, develop machine learning models outside of the database on a data science workbench, even on a MacBook. And that works at smaller scale. It doesn't work well at larger scale. At larger scale, you really have to bring that stuff close to the data. And the other thing that's happening is, so the tradition in developing machine learning models is very artisanal. Each data scientist wants to start from the raw data, work independently, and not have any influence from any other project often in their analysis. But what we're finding is, in order to deal with that scale, you probably have to have a shared feature store inside the enterprise data platform that not only increases efficiency, it also increases the productivity of the data scientists when they share features. So that's another example. But I think all these things, this intensive use of AI, both Gen AI and machine learning, is going to raise the stakes concerning efficiency and scalability. I think, it'll bring enormous numbers of people into direct contact with the data. If you have thousands of people in your organization using BI today, you probably have tens of thousands after you make natural language query available. So huge increase in the volume of usage, which is going to put a premium on scalability and efficiency in the data platform. That's a change. Over the last 5 years, we've seen a lot of customers go to the cloud, adopt a data platform without even thinking about its efficiency, because they're mainly concerned with ease of use in the cloud. I think the next 5 years are going to see a lot more concern about efficiency. Otherwise, the cloud bills are going to become just astronomical.
Thanks, Richard. Let me turn to Andreas. For the past 30 years, the relational database has reigned supreme in the world of data and analytics. In the age of AI, should we be thinking of placing other engines at the core of our data environment? Do the benefits of making a big change like that outweigh the risks?
So starting from, let's say, the SQL world, it became quite clear after a couple of years we need a more entity-centric view on our data. So it's really about how are the entities, the business objects related to each other, and how could we use those types of relations also to generate knowledge out of data. So what we are believing in and have executed on for many years is building a kind of a semantic layer on top of all the data silos and repositories, and we're not restricted to SQL data. It could be also unstructured data, all kind of data, where all these entities actually occur. So they are contextualized in different ways, in different silos. And we need to understand how are those entities related to each other? Where do they reside? In which of those silos can we find facts and information around the business entities we are actually interested in? Because at the end of the day, we want to ask questions and get answers as knowledge workers. And the whole idea really is to have this semantic layer on top, also providing a kind of a governance model on top of existing data silos. So metadata is really the essential element of this semantic layer. Metadata, which consistently describes data residing on all these silos. So it's actually something you have to develop outside of the silos. So it's its own asset, is its own knowledge asset or data asset you need to take a closer look at, and not just always, try to optimize your islands. Yeah, you really need to start providing a systemic data management tool on top of all the silos. That's what we propose, and that's what we see more and more also driving AI on top. So AI really benefits from this semantic layer, which nurtures the large language models in, for instance, contemporary graph RAG architectures as they're currently used.
So AI might usher in the era of graph as well as a main deliverer of the semantic layer that you're talking about?
We really try to take unfragmented data into our AI engine. So we have to defrag. Yeah, you remember defrag from MS-DOS times? Yeah. You have to do that with your data landscape. You have to bring it together. As already Carl also said, does it mean to bring data next or closer to AI? We need to bundle that up in digestible chunks, which should get closer to the way our brains work, as Tom pointed out. So it's also the people. It's not just the data. And connecting the data with the people, we need a semantic layer in between, we believe.
Hey, Andreas, let me ask you a little bit about this. A lot of people understand the problem, sort of state the problem is the computers don't talk, right? And it's sort of, I tried to unpack that a couple of years ago with a bunch of people, and we sort of, came to the conclusion if computers aren't talking, then it's a sure bet that organizations aren't talking, right? And part of the reason they were unable to do so was they lacked a shared language, right? And most days it didn't come up because most days we work in our silos and so forth. But when it does come up, right, you need this sort of shared language. And then if you have that shared language, then it's much easier to make it such that computer systems can talk. Is that consistent with your experience as well?
Yeah, it is. And in the best case, you use natural language. No, this is what everybody can do that. Nobody needs to learn SQL or Sparky or whatever. It's still just probably 0.2% of world population can do that. So what you actually need to do is to transform internally, natural language into all kind of query languages. It could be SQL, it could be Spark, it could be Cypher, you name it. And it doesn't matter anymore where the endpoints reside. I want to ask a question, I want to get an answer, and I want to rely on it. And I think this is the key element of a contemporary AI architecture, that it's really trusted, it's trustworthy. So I want to know, where does that come from? Where do the facts I now get presented when I ask my question, where do they come from?
Can I offer something in support of what Andreas has been saying, which is that about 3/4 of my career has been involved in data management. The other quarter has been involved in metadata management. In fact, I sat on the metadata management standard committee, international committee years ago, and we struggled for several years to try to come up with standards that made sense and that were manageable. And one of the problems that I personally looked at that I felt we couldn't answer was, well, how do you store the metadata in an efficient way? And I could never quite answer that question. I saw a number of case tools that had various sophisticated metadata management frameworks, but they ended up trying to force it onto a relational database, and it just didn't work. Just couldn't get because the relationship support is not there. And then when I saw the graph model, I said, oh, there it is. So I've been an advocate of using graphs for metadata management ever since. And I think now that we're getting to a point where we want to use AI, not just generative AI, which is mostly focused on unstructured data, but AI in general, to blend what's in the database with what you're finding in unstructured systems, and therefore need much more sophistication. You need the definition and you need the context of the data, and a graph is the way to do it.
I definitely echo that. And I think the biggest change I've been seeing is a flexibility and the openness of the data structure. That is a must-have. There's no way we can get all the data structured in the perfect situation. So I do agree the knowledge graph plays a big role in the AI era. I think that is something we are also looking to as the industry.
May I add one aspect to that? It's even like that in all these repositories we've built over the years, there's a lot of important information, no doubt about that. But still, there's a lot of other knowledge in our heads. It's just nowhere written. It's not in the technical manuals, nor in the SQL databases around our products whatsoever. So we really need to add something else next to our data, which is actually, you could call them knowledge models and domain-specific knowledge models. And this is one ingredient of a knowledge graph. So you digitize knowledge, and that's also important to scale AI up to the level as we would like to have it. So it's kind of the last missing, let's say, piece in the puzzle to have a more holistic perspective on the data and knowledge landscape in an enterprise.
So let's segue to Wei. Wei, you've been in the trenches at McDonald's, building architectures to support AI, among other things. What have you tried? What has worked? What hasn't worked? Where do you go from here? Not a tough question.
Yeah, not a tough question. So biggest challenge I've been experienced is, given the size of McDonald's, and I'm pretty sure other large so-called traditional enterprise, right, is one is data silo, for sure. We've been talking about for many years, and it becomes so critical nowadays that if we cannot tie the data across the globe together in a way that they can create the knowledge on top of that, right, then the AI can leverage that. I mean, there's no easy way to address that given the size. So we've been trying to centralize data to Lakehouse, been doing that for years. It's just like you never can catch to the state that, oh, we are good. We're at a good state of centralized. So to the point, I'm not saying we're giving up this idea, but we also start to accept the reality of centralized data to Lakehouse or data warehouse or a lake. You can only do to a certain degree. So now is what, right? If we cannot centralize data, but we still want to form this unified knowledge graph on top of all our data, what can we do? So that is the biggest challenge. So some of the things we've been trying is, one is data mesh, and also start to introduce, like Andrea mentioned, the knowledge graph on top of that via the semantic layer, right? And then meanwhile, a little bit easy thing to do, and we've been feel good about it and achieved quite amount of the value from that is we call real-time data highway. So that is leveraging streaming APIs, right, and reduce the batching process. That's been quite successful, to be honest, so that we can act on the knowledge in the real time. But still the challenge, like how can we keep the data structure as open as possible, right? How can we process the huge amount of data in real time to drive the real time action right there when customer interact with our systems? Still a huge challenge. And honestly, right? So another challenge for us is, I think we talked about metadata for many years. But this is a real time in my life, even. I start to see, wow, the metadata for the AI is a must have. I just can give you an example, right? So the AI needs to mimicking the top analyst to drive the insights of our sales, let's say. But how do you capture the top analyst behavior, right? What they click, what kind of information they're achieving, right? What's their reaction to that information? What's the next step? They are shaping that information and knowledge. So those are the things. In the past, we call it metadata. It's nice to have, right? In the AI time, this is a must-have to train the model, right? So those are the things. So to me, is like something I think we're still exploring with some wins, but certainly it's still a challenge for us and also for the industry.
So there's no coincidence that there's only one person in the trenches here, you, Wei, and all of the rest of us are kind of pundits talking about how to do it, because those challenges, each one of them is daunting in and of itself.
You know, Wayne, I think that Wei raised an interesting issue, which has to do with the fact that you're bringing data constantly from different sources and trying to blend them together. Not always perfectly blended at the time you want to do analysis, right? So you have to work with what you've got. Tim Berners-Lee, when he started talking about the semantic web, said that systems needed to have a tolerance for ambiguity, which means that sometimes you don't know exactly whether this is that. Sometimes you can only say this is probably that. And if you don't have that tolerance for ambiguity, then your system becomes rigid and very hard to manage.
Exactly. Yeah. And also we need to tolerate, right? You cannot bring all the necessary data in. Like the data need to sit somewhere for a while. So that is also the reality. And how do you leverage that data sits somewhere, right? And it still be part of your knowledge.
So I want to go back to your first challenge of probably half a dozen you mentioned, is the data silos. I know companies have been struggling with that for decades, still struggle with it. And I think the data mesh is a kind of an appropriate response to that whole dynamic, which is if you can't beat them, join them in some respects, right? And I'm wondering if you're finding that I think people are trying to slowly navigate their way into the data mesh because it can go awry quite easily without proper governance and standards, right? So I'm wondering if that is something that's really helping you get your arms around your data to fuel your AI initiatives?
Yeah, if this is for my situation, definitely data mesh helps a lot. But there's a fundamental challenge existing in the data mesh is, do we have consistent, unique ID for a given entity? Just otherwise, you cannot mesh them together. Okay, that's another thing, like for a company like a McDonald's and other, retail companies or traditional companies, they try to do is, with all these years, right, we are encouraging markets to establish their own business practice. Hence, there's no consistent, unique ID for a given enterprise data entity. So that's the foundational work we're doing today.
I mean, again and again, we see these things like if there's data silos, there's organizational silos.
Yeah.
In fact, the organizational silos were there first, and data silos reflected the organization.
Yeah.
Right.
Yeah.
And in some respects, if you need to work across the data silos, then you have to figure out how to work across the organization. And as Wei mentioned, I mean, sort of, common identifiers is sort of like the minimum.
Yeah. People who do the data mesh and don't have some kind of coordinated governance, then they fall into this trap where they can't link data from different parts of the mesh. So the absolute minimum is to have standards regarding the linking fields, which includes the unique IDs.
As a former software developer, I can tell you what I hated to have to do was to write the same code twice. So, when you talk about data meshes and things like that, if it's not organized, if it's not managed, then what you end up doing is every time you make a change, you have to write practically the same code again with a minor variation for the new data coming in, which is a waste of time. What you want is for the system to be well organized enough that it's only the differences that you have to account for, and not kind of like rewriting the whole environment every time you bring in another database or something like that. So I think that's where the metadata plays a huge role, because if you can map the data to the metadata or vice versa, then there's less effort involved. And as a developer, I hate effort, so I have to do as little as possible.
All right, so we're starting to touch on the G word, governance, and that's Tom's bailiwick for the most part. So Tom, I recently did a presentation on Gen AI, and I counted 15 risks associated with that technology. Everything from hallucinations and bias to replicability and data exposure. So governance has to play a big role in Gen AI and AI implementations if corporations are going to, implement it at scale and take on those risks, right? So other than forming a Gen AI data governance working group to address these risks, are there other data governance activities that you would recommend?
Well, thank you for asking the question, Wayne. I mean, first of all, thank you and Inside Jam. It is not obvious that people and org things are a part of architecture, but indeed there are. The first comment I'd like to make is the practical reality is that today, data governance as practiced is failing. And so first and foremost, I don't think people who are listening should rely on it. It's going to take some very different things and way more. And in particular, governance is in my view, been an absolute disaster for data quality. Now, I have 3 lines of prescriptions, and each of these lines is working somewhere. Although I don't know of any organization that is using all 3, and certainly they're not the norm. But the first thing is get everyone involved. And we talk about AI is transformative. Well, any transformation 101, if there were a management course called transformation 101, on day one, the first lecture would be that you need to get everyone involved. You simply cannot transform unless people are involved. Transformation's not about technology. It's about what goes on in people's heads. And this is also, look, I mean, the only thing that so far really consistently works in data quality is understanding who data customers are and data creators and getting them connected and working out business processes such that creators meet customer needs. The second line of prescription I call data is a team sport. I mean, it's sort of obvious when you think about it. We've talked here about the need to work across silos to bridge things. There's a bunch of ways to do that. Process management, end-to-end process management is unmatched. A lot of companies have trouble pulling it off, but when it works, it's awesome. Shared language, we've talked a little bit about. I mean, and I'm not viewing this as a technical problem, but just a business problem. Change management, and then it's a specific roles to bridge between organization 1 and organizations 2, and at various times these people have been called coverage officers or liaisons or facilitators. And the third main prescription is get leadership off the sidelines. And the cold brutal reality is, by and large, senior leaders have sat on the sidelines. I'm sympathetic because it's not obvious what they're supposed to do, but if that transformation 101 class on day 2, what they'd be teaching about is the transformation goes as far and as fast as the senior leader directly involved demands. Okay, and so we're stuck at making changes at scale with senior leaders on the sideline.
So Tom, that's an interesting quote you started with, that data governance is a disaster for data quality. Yet your 3 recipes for success are all about the people and process. It's a team sport. You need leadership. You got to get everyone involved. And to me, that's what data governance is. It is the people and the process. And that's why it's hard, right? Because people and process are much harder to manage than technology.
Yeah, sure. Look, Wayne, I mean, there's a big debate on what data governance means, right? And usually, and shake a tree and 22, definitions fall out. But so mostly it includes control, right? That's the way most people think about it. You're thinking about it much more expansively, right? And I don't want to push back and have a debate on what it really means, right? But the stuff that's needed to work is around the things that we talked about, getting people involved, right? Especially for data quality, right? In some cases, they can be small data scientists, right? Data's a team sport, connecting everybody, right? Getting leadership off the sidelines. So they're not really, not a lot of this is really consistent with control, how a lot of people think about data governance. But if you want to think about it holistically, by all means.
Okay. Yeah, I will think about it holistically. It may be a disaster from the control perspective, and I might agree with you on that.
So look, the reason I say that for data quality is I talked to an organization, and I promote data quality. That's how I make my living. And I ask people, do they have a problem? And they say, no, we've got a data governance program in place. You don't have a problem. And so then we go look under the covers, and it's awful. Right? Right. So,
well, Tom, we've done a number of surveys when I was at IDC on data quality. I can tell you that if you believe those surveys, nobody has a data quality problem. Everybody's perfectly on top of it.
Yeah.
I have to say, data quality, data governance. I mean, it's a consultant stream, right? Every company we go into has data quality and data governance issues, and where we spend a lot of our time.
Yeah. But I also think when AI introduced a new challenge to this space, right?
Yeah.
I just give you an example, right? AI needs to be explained why you come up with this result outcome,
Yeah.
right? Traceability, lineage becomes so critical, for example, right?
Yeah.
Yeah.
So look, we have data quality problems we've never really dealt with before.
Yeah.
I mean, suppose you want an unbiased algorithm, right? Okay, well, then you need to train it on an unbiased data set.
Yeah.
Where are you going to find an unbiased data set? How will
Exactly. Yeah.
that's the case? And so, we're not even doing very good about, like getting the details associated with this customer transaction correct, right? And the bias issue is generations more complex. So thank you for pointing that out. Right now, as far as I can tell, everybody says, yeah, data quality is the number one issue, but there's way more whining than there is serious work.
At the end of the day, it's all about having agreements in place between people. So when we talk data quality and good metadata, we have to agree, for instance, on a classification scheme. So if the one says, okay, this data falls into that class or under that class, we don't have an agreement. So this is always the first exercise when building, let's say, the foundational pieces of an enterprise knowledge graph. And what we regularly see is it's really an exercise. It's a team sport. Yeah, if we bring people together, building together such graphs, you need to lay a foundation, like, for instance, with a simple taxonomy. Build a taxonomy first. And then you have to bring people together and they have to agree on some structure. Otherwise, it's meaningless, the taxonomy. You cannot impose taxonomies from the top. It's not possible. Otherwise, they're not used. They are not accepted. And I think that's a good way to really find a kind of a discipline also, that people start to work along the same lines, which could be a goal they have in mind, which is, okay, let's build together taxonomies. Let's build together, and now I use the O word, ontologies, or even bigger knowledge graphs, right? And we see regularly when people start doing that they stumble upon really, really bad data quality at the end of the day. And then this is them expect. So some people say, oh, okay, let's stop this initiative, but don't touch this, no? But it doesn't solve the problem at the end of the day.
Yeah, I mean, let me build on that, Andreas, because what you're saying is so important, right? I try to focus on two simple things, two simple roles. One is the customer role. You're using the data, right? And the other is the creator role. So you're creating the data, and nobody creates bad data for themselves, right? I mean, so if I need it and I'm in both those roles, things turn out pretty darn good. Or at very least, I'm aware of the limitations. It's when I'm creating stuff for you, okay, and I don't know what you want, and I'm stuck in my silo, right? And I'm putting stuff in my data silo, but then getting us together and say, okay, well, either we have common interests or you have interests that depend on me, and getting together. I mean, people are amazing at working those things out. And they, and the good news is they really, really like the work.
Let me. We have a few minutes left here, so let me turn to Carl. I haven't asked you a question yet. So we know that companies are struggling to define scalable, high quality, governed data architecture of Gen AI, as we've been talking about. But most are focusing on using RAG, retrieval augmented generation, to increase the quality, or fine tuning to great models that generate more accurate answers. We've talked about semantics, but what do you think? Is there a way that we can give executives who want to deploy new Gen AI applications, but don't want the thing to hallucinate? They don't want people to get different answers each time they go to a chat bot and ask the same question, which happens a lot. What do you think is the way to address this situation?
Well, so Gen AI is focused mainly on unstructured data, and there's a very good reason for that, which is that all the systems that we talk about with respect to Gen AI involve pattern recognition and then response to recognized patterns by generating results that make sense with respect to what's in the large language model, which was built in the first place in order to harness those patterns and the information that they provide us by large scale correlations to answer questions. And the reason they could do that is because they're based on human language, and human language has semantics, and semantics provide a certain sort of order to the way words are arranged. In other words, if you had a large language model and all the data that came in was just random words, then it wouldn't be able to do anything with it. But they're not. They're in sentences, they're in paragraphs, and those structures form patterns that can be broken down. There are no semantic structures. Structured data has no semantics whatsoever. It's just about aids. The value in a relational database are organized according to tables with rows and columns, and those tables tell you nothing about what the data really means, tells you nothing about what the data means in reference to other data. There's nothing there. That work has to be done. And if that work isn't done, then you can't really incorporate that data into an AI super system, if you will. I mean, yes, you can generate SQL. You can ask a bunch of questions and have a SQL statement pop out that you apply against your database and get values. But you can't actually have it analyze the data in the relational database unless it has more information than is currently present. That's why I kept harping on the idea of a graph, a property graph, as a means of collecting sufficient information in order to allow that to happen. Because two things need to be added to the system in order for this all to work. One is the definition of the data itself in business terms, so that those can be related to other business terms and so forth. The other is context. This means this when this is happening. This means this in relation to that. That kind of stuff also has to be there. The more of that richness that you can provide the system, then the more intelligent your response is going to be, and the more able you will be to integrate stuff. Now, we've had these challenges for years, but we didn't have it with respect to AI. We were just trying to do things like design better data systems or make our applications more efficient. And at the end of the day, we often sort of failed, right? And the reason we failed was because operational application systems are developed by individual projects with individual project leaders and individual goals. The first of which is to make the application come online as fast as possible and do the narrowly defined set of things that it's designed to do, period. So they're not interested in, does this data make sense in any other context? They're not interested in, do the values that I use in this application relate in any way to the values that any other application uses? Then we encounter that problem when, as I'm sure Richard can give us plenty of examples, we try to blend stuff together to put it in a data warehouse because we have to solve some of those problems. What we do is punt. We select the applications that we want to use for the data warehouse, and we collect the data in the applications that we want to use for the data warehouse so that we can simplify the problem to the point where we can get it working. And we still have a rat's nest of ETL jobs and things like this, transforming the data with no real guidance over the top, so that when things change, we have to go back manually and fix them. That is not a prescription for AI success. What you really need is for the data to be well understood. And now that we are at a point where AI is attracting enough attention that people are saying, oh, there could be real value in my simply being able to do, as I like to say over and over again, what you could do in Star Trek, right? You just ask the computer a question and it gives you an answer, and it's an unambiguous right answer. That's what we want. So to your question about hallucinations and such, Wayne, those happen because human language can be inconsistent and the patterns can be misleading and cause wrong answers to pop out. Databases are always consistent if they're managed well, but they don't necessarily relate to each other or to the real world of business. So that's the part that we have to fill in. And that's the big challenge. If we can do it, we can make it happen. So it may be that finally senior management will say, actually, we should allocate some resources over the course of years or even a decade or so to fix this problem and make the data match and fit together so that we can ask those kinds of questions on a day-by-day basis and get really good, consistent, comprehensive answers.
Well, Carl, that was quite eloquent. I have never heard anyone describe how that all fits together like you just did. But you're obviously talking Andreas's language, and I'm wondering if, Andreas, you have any comments on that, or Carl, how would you actually go about implementing? I think what you're talking about is semantics on top of all of our data. So there is that richness there that we can use to analyze.
Well, yeah, before I let Andreas answer your question, I just want to point out that another thing that's going on in the AI world is AI-assisted tools. And those can be a big help in identifying, how we relate data together at a semantic level. If we had to do it manually, just by having committees meet in a room with big whiteboards and draw everything out with arrows, it would take forever. And it would be people would be arguing and having fights and, erasers at each other and stuff like that. But if an AI-assisted tool helping you do the work, it can come out much better.
I agree with you, Carl. Except one element, I would not let the AI do everything from scratch. It's good to have people still involved to lay the foundation.
Remember that we said AI-assisted. I didn't mean AI-given or controlled. Yeah. Okay.
Absolutely. But the majority of the graph should be generated automatically, probably 99%. And it can be done because we have a lot of elements to it. I mean, all the work we've done in the past decades is now valuable. It can fill the knowledge graph with the right information. But we have to bring it together in one kind of unified views over all the silos. And also to translate the data logics into business logics language. In the best cases, even in natural language. Because what we've built as data models for a particular application was optimized towards one particular goal. But now if we want to have all the data and facts and context flying around in the different repositories and silos put into one structure, obviously we need to use more the business or the domain specific language, which can be understood by the subject matter expert. So those are the drivers. And what we currently see is really a strong need to have new roles in place, which kind of can bridge also the data scientists, the data engineers perspective, and the subject matter experts on the other side. So those have to be connected also to some degree. They speak different languages. They look at data in different ways. And those models which bridge the gap need to be governed in a way that this can be brought together. We start talking about knowledge stewards. I don't know if that resonates with you. We all know what data stewards are doing. Knowledge stewards are those who understand the people, their business needs, and also understand the data under the hood, and try to bridge that with so-called domain models, which could be a graph, a part of the larger graph, and the rest around those little knowledge models can be generated quite automatically. As said before, 99% of the facts and triples in a knowledge graph can be generated automatically with help from LLMs and with other transformation tasks and machine learning in place.
Could I add one more thing? I just felt like critical in terms of the executives or our teammates, right? AI is basically, especially Gen AI, is a predictive kind of engine. Right? There's no 100% accuracy for sure, regardless of what we do. So that expectation needs to be adjusted, right? And then we have a mixture of structured data, high quality data, and the reliable API to supplement the results of that. So I think that understanding needs to be adjusted in the industry as well.
Okay, folks, I want to finish up here. we want to go to a lightning round. And when I say lightning, you got to give an answer in less than 30 seconds, even less than that. So the question is, what do you see is going to be the biggest significant development in our industry in the next 12 to 18 months?
Well, I'll tell you what I hope it is. I hope it is a new and urgent desire to get the people and organization stuff right.
People process, always the hardest thing. Thank you, Tom.
So for me, it's the fusion of statistics and deterministic symbolic AI. I think this was always this dispute for all the years, and now graph and machine learning come together. And this is now really becoming reality. We see it all over the places.
Great. Symbolic AI. Terrific.
Well, I'm sorry. Go ahead, Wei.
Yeah, for me is the agentic AI usage in the data foundation, pipeline, data quality, data processing.
I'm hoping to get agentic AI to unsubscribe from all my thousands of emails.
For me, I think and I think the discussion today helps reinforce this. This may be more of a aspirational than predictive statement, but I'd like to see tools and techniques developed that enable people from different groups within an organization to come together and agree finally as to what their data actually means, so that they can codify that meaning in a form that the system can use to answer questions.
Based on my own, I'm sorry.
Go ahead, Richard.
Yeah. Based on my own experience playing around with ChatGPT, I think we'll see large numbers of people using AI to get answers to relatively simple questions, just to more readily put their hands on facts. Now, as everyone's been pointing out, those answers aren't always perfect, but I think there's enough capability in what's out there to make a lot of people's lives a little more efficient, a little easier.
And I'll take the last one, which is just as we saw the proliferation of data silos and BI tools and reports, I think we'll see the proliferation of, well, we're already seeing proliferation of chatbots. And this poses an architectural question for organizations that we didn't get into today, but do we see the ascendance of a chatbot gateway where everybody sends their questions to one gateway and it fans it out to different chatbots that are best equipped to answer the specific question? So with that, I'd like to thank our panelists for their wonderful insights today, and also the audience for listening in. And back to Jonathan here.
Thank you, Wayne, very much. Appreciate your time. I know you have a quick exit here, so we'll say goodbye to you now as I begin to prompt our panelists here for some self-promotion. As we wrap up the show, I want to give you each 30 seconds or so to plug your company solution, your personal podcast, LinkedIn profile, book, whatever you want to send the audience to. The floor is yours. We'll go in alphabetical order once again. Andreas, over to you first.
Thank you. Yeah, self-promotion. So GraphWise is a company which helps organization to make data and content AI ready. So we do that with help from knowledge graphs. You build semantic layer on top of all your silos, enrich that with additional context and knowledge. And by that, you leverage your data finally and make it AI ready. And then, of course, on top, you can build beautiful, for instance, self-service portals, chatbots, et cetera. So what else is important to know? GraphWise is a platform. It consists of a lot of components you can stitch together in the way that you can build the applications you deserve. It's a most comprehensive graph AI platform on the market. And please reach out to us, GraphWise AI, or we're on LinkedIn. We're all around. So let's meet and talk. Thank you.
Sounds very good. And thank you for your time. Carl, over to you next.
Sure. Thanks. Well, I'm recently retired from IDC, where I was 27 years at database software analyst, industry analyst, covering mostly the vendor community. And now, as an independent, my function is really to provide consultative services both to software vendors as well as to software users. I'll be producing blogs and short pieces online. In the future, I plan to have a slightly more expansive capability, but right now I'm under certain constraints on that regard. But in any event, I'm always willing to engage in conversations that help explore the kinds of things we talked about today, as well as other related things.
Thank you very much. Sounds good. Richard, over to you.
Hi. So I help executives with critical decisions concerning the large-scale data ecosystem, platform selection, what to do if your cloud bill's too high, you're not happy with your data warehouse, you're going to move to the cloud, you're going to go big into AI, and so you want to make sure you've got the right platform or combination for what you're going to be doing the next few years. Those are the things we help customers with.
Sounds good. Thank you for being here, Richard. Appreciate your time. Tom, Datadog, how are you?
Yes, thank you very much. Me and my company advise companies and leaders within those companies on how to attack data quality properly, and in particular, the organizations they need to build in order to do that at scale. I'm most proud of the fact that the people in those companies really enjoy these roles I noted before as data creators and data customers. You can find my stuff at Harvard Business Review and Sloan Management Review. My latest book is called People and Data, and it's all about getting people switched on, and it's my best and most important thing ever.
Well said. Wei, over to you.
Well, I just want to say, probably all of you know, McDonald's serves 70 million customers a day across 100 plus countries. So if you want to play big, play advanced data and analytics, AI, please join us. We need a lot of talent from you. And from board, CEO to all the markets, we do believe data and AI will be the next transformation engine for a company like us. So reach out to me on LinkedIn or send me emails if you are interested.
Sounds good. Thank you for that, Wei. Appreciate your time. Appreciate everybody's time. This is a great discussion. If you'd like to dive deeper into this topic and learn all more about enterprise technology, we always encourage you to visit our always-on destination for just that thing, InsightJam.com, newly rebranded with logos and new graphics. We hope you join the conversation there. Or you can subscribe to our YouTube channel for panel highlights, weekly podcasts, expert advice, and a whole lot more. We will be back with a keynote hosted by Dr. Joe Perez in just a few short minutes, detailing the madness behind the method, a smarter approach to team learning. Until then, though, I'd love to thank our group of panelists one more time and you for your attention. Until next time, we hope to see you then. Have a great afternoon. For video highlights, replays, and more, visit InsightJam.com.